Good afternoon and welcome to the homework helper for section 2.2. Today we're going to go over three sections. The first one is comparing rates of change in linear situations. So it kind of gives us a hint that we're going to be doing linear stuff. So let's go ahead and zoom in on this first problem. It asks us to state which situation has the greatest rate of change. And I'm going to give you a hint here. One of the big things that we're going to be doing here is we're going to be working with units and making sure that our units are consistent. So consistent units. Because let's go ahead and look at this first problem here. It says the amount of stretch in a short bungee cord stretch is 6 inches. Okay, that seems important. When stretched by a 3-pound weight. Okay. A slinky stretches 3 feet when stretched by a 1-pound weight. So we see we got our units. We've got inches, pounds, feet, and pounds. So what we're trying to see is we're trying to see which one grows fastest. So which one has the greater rate of change, and greater means the larger number. So greater rate of change, that's going to be the largest number. To do this, what we need to do is we need to first set up our equation. So we'll start with 6 inches and 3 pounds. The way that I like to do this is I really just like to view it as a fraction. So if I have 6 inches per 3 pounds like this, I have this fraction here, and I can actually reduce it. 6 divided by 3 is 2. So I have 2 inches per pound. That's how much it stretches. For every pound, I'm going to stretch 2 inches. Makes sense, right? I'm doing 6 inches for 3 pounds, so 2 inches per single pound. So that's going to be my bungee cord, my BC. Okay? So now what I'm going to do is I'm going to examine what it's like with the slinky. Okay? With the slinky here, I go 3 feet per 1 pound. And I can see that it's already a fraction, but what I have here is when I have 3 feet per pound, I don't have the same units. So I either need to convert inches to feet or feet to inches. So what I'll do is I'll convert 3 feet to inches. And since I know that there are 12 inches in a foot, if I multiply that by 3, I get 36. So I see that this is going to be the same thing as 36 inches per pound. Okay, because 36 inches is the same as 3 feet. So which is greater? Well, clearly 36 inches per pound. So clearly the slinky has the greatest rate of change. All right, so that's what you're going to be doing for those problems there. Let's go ahead and zoom out. Let's move down and zoom back in. All right, so here we have in the set section, whoops, other way. We're looking for discrete and continuous relationships, and it wants us to identify whether the following items best fit a discrete, remember discrete would be dots, or a continuous would be a straight line. Then determine whether it's linear or arithmetic, exponential, otherwise known as geometric relationship that is being described. So the freeway construction crew pours 300 feet of concrete in a day. So is this going to be a discrete or continuous relationship? Clearly they don't drop all 300 feet in one moment. This is going to be continuous. And then, is it going to be linear or exponential? Well, it's 300 one day, 300 the next day, 300 the next day, so we're adding 300 each day, so we know that it's going to be linear. So again, we're just looking at these problems very similar to yesterday, except this time we're wondering whether or not they're going to be linear or exponential or otherwise known as arithmetic or geometric. Alrighty, so let's go ahead and flip the old page here for the last section. And so for here we are back to solving one-step equations. These are starting to turn into some two-steps here. And it gives you a little example here of how to do it. Solve the following equation, and here we see that we subtract 7, therefore we know x is 16. Divide by 9, therefore we see x is 7. But I'll go ahead and do one with you all. When I look at number 11 here, I have 1x plus 16 equals 36, so I would subtract 16, 1x, otherwise known as just x, is going to be equal to 20. Okay? That's an addition and subtraction one step. So let's go ahead and look at 14 here. 14, I have 8x equals 56. If I divide by 8, divide by 8, x equals, my brain, it's too early in the morning, I haven't had my coffee. 56 divided by 8 is 7. And there we go. That's all, whoops, the calculator's hiding my answer. There it is. Move the 7 to show the 7. There we go. That's the homework. Show your work on these. Don't just plug it into a calculator and hope for the best. I mean, showing your work, showing each step is really helpful for you to really understand and solidify what's going on. It helps you see the regularity and structure of these types of problems. And it also helps you identify any mistakes or stuck points. So make sure you're doing that. Have a lovely day. Good luck. Goodbye.